This conference will now be recorded.
Yeah, good morning. Can you hear me? Are you able to hear? Vineet, can you hear
Yes,
me?
sir.
Okay,
Yeah,
okay,
yes,
okay.
sir.
Just wanted to confirm. Yeah, okay, fine, thank you. Okay, we'll start. So in the previous session, we completed the mass processing, and moving forward, uh, from today, we will see how to do building for a interval meter, what we call also today as a smart meter. And in order to do the billing for an interval meter, we also have to have the integration with the EDM profiles, which are called energy profile. So we're going to see partly the EDM part coming into the picture, because in the case of interval meter, we actually gather the information from the meter in the form of interval data. And that data will have to come into SAP and get stored in the form of a profile. And then we execute the billing for the profile data using the RTP, that is the real-time pricing interface. We are going to customize the RTP for the purpose of building the interval data. Now, basically, what is the concept of the interval meter data or interval meter, which is also called today smart meter? Conventionally, we had meters which we were deployed all over the world for a very large period of time. Basically, these meters are capable of recording the consumptions in an aggregated fashion. At any given point of time, you can take the meter reading and deduct the previous meter reading. We get to know the consumption for the particular period. Like say, for instance, in the regular meters what we have in India, these meters will help us to record the consumption on a continuous basis in an aggregated way. And monthly, when you do the meter reading, we come to know what is the consumption that has happened for the consumer, and we build that particular consumption energy quantity using the billing procedures. But although we have the consumption data available for the particular period, we are not aware or we cannot come to know what is the rate of consumption. I mean, how the pattern of consumption is happening at the customer's location. Let's say for the particular month, the consumption has come to 700 kilowatt hour. But how this consumption has happened, we cannot understand the pattern of consumption. At the most, we can say 700 kilowatt hour divided by 30 days of meter reading divided by 24. This is the average rate of consumption, what is happening at the customer's place. But as you know, no one will consume electricity at a continuously at the same rate. There are certain periods of time in the day when we tend to consume at a higher rate. At some point of time in the day, we consume at a moderate rate and maybe very low rate of consumption at some point of time. So it is going to be not a constant, rather it's going to change over a period of time in a day. And that pattern will continue more or less throughout the month. But what is important is when we are billing the consumer, although we are billing for the total consumption, we are missing out what are the different rates at which the consumer is consuming. Because whenever the rate of consumption is higher, it means electricity department is also supplying electricity at that rate. That means, let us say, there are certain periods of the time in the day when all the consumers will require higher currents or higher consumption rate, because they must be running most of their utilities at home, light load, even the other loads. At some point of time, they may be consuming at a moderate rate or maybe low rate. But at some point of time, definitely they're going to consume at a higher rate. and that's going to be like an on-peak consumption where more rate of current is required or consumption is required. For the utility company, it has to supply the power or the energy corresponding to all the rates of consumption. Say, for example, we have got a bulb of 100 watts running for 10 hours. So consumption is going to be 1000 watt hours, which is going to be 1 kilowatt hour. And 10 rupees is the price, so it is going to be 10 rupees. But we also have a bulb which is 1000 meters, 1000 watts running for 1 hour. Here also consumption is 1000 watt hours and it's going to be 1 kilowatt hour. But although the consumption is the same, when you are billing, we have to consider that at some point of time, consumer was drawing the consumption at a rate of 1000 watt. That means almost 10 times the standard bulb what is drawing. The electricity department has to supply the current at that rate, which is almost 10 times higher than the 100 watt bulb. And as the rates of generation increases, the cost of production of electricity also will increase. That means if you are to generate at a higher rate of electricity, then your production cost also will increase. But then how will you compensate that? That we cannot get the picture because we don't know what is the pattern of consumption from the consumption. And the consumer also doesn't know at what point of time their consumptions are higher if they want to control the overall consumption, what is happening their side. And in the industry, they have a industrial practice of settlement where the energy partners will settle their information once in a month. That means the generating company will say, this is the total amount of electricity we have generated. And then the distribution company will say, this is the total amount of electricity distributed, which means consumed. So the total generated electricity should be equal to total distributed plus the transmission losses. Because when you are supplying the generating and transmitting the electricity, there is bound to be some kind of transmission losses. So this activity has to happen once in a month where the distribution companies have to send the total data of distribution based on the consumption what they have recorded to the generating company, or the transmission company has to say this is what you have transmitted. All this data will be sent to a settlement coordinator. There will be third party company who will collect the data from the generating company, distributed companies, and the transmission companies, and then try to settle so that we come to know how much is the actual amount of electricity consumed, what are the transmission losses, any unaccounted electricity consumptions. Accordingly, the generating company will fix the service charges to distribution companies and transmission companies. They have to settle their payments regularly once in a month. But this activity has to wait earlier for the month to over because only by the end of the month you know what is the consumption which has happened in the particular area. So there used to be a lot of delay in the settlement, errors in the settlement. Rather, the industry requirement was always why not do the settlement once in a day or every hourly settlement. Now many countries are doing settlement every hour. That means if you have the data, what is the consumption happening every hour in various area, we can also do the settlement. Okay, but there's no way this could have been done with the regular meter. That's how there was always a requirement to develop a kind of a meter which will keep on recording the consumption for smaller interval of time. And that's how the interval meter came into existence. It is also called smart meter. So in which way the interval meter will differ from a regular meter? The interval meter will keep on recording the consumption for small intervals of time. Although you can have intervals of half an hour, 1 hour, 1 day, but internationally now it has come to 15 minutes as the standard. That means every 15 minutes, the meter will record what is the consumption which has happened, and all this data will be stored in the meter itself. It has got a local database. Say, for example, at morning 9 o'clock, the value recorded in the meter is 2.2 kilowatt hour. At 9:15, it is 1.9 kilowatt hour. At 9:30, it is 2.1. So what are these values? The data what we see at 9:15, 1.9 corresponds to consumption that has happened between 9 o'clock to 9:15. That means in the interval from 9 to 9:15, the consumption is 1.9. Similarly, between 9:15 to 9:30, the consumption is 2.1. At every 15 minutes interval, we have the data available in the system, in the local software database, which is provided by the smart meter or the interval meter. But then how to read this meter? We cannot go to the meter physically and then do the meter reading. We have to deploy some kind of remote meter reading. That means there should be some kind of technology which should be available, with the help of which, the data of the meter reading should be read remotely and then sent to the distribution company, which is running the SAP system. So this meter reading activity cannot be done by the distribution company. It has to be done by a third-party company. So this third-party company, which is called AMI company, which is basically the automated meter reading company. AMI means automated meter reading company. Previously, we had AMR, automatic meter reading. Almost both are same only. Automatic meter reading was used for even reading the meters, which are regular meters. That means from a fixed location, they can send a signal to all the meters, and meters will send the data back to the particular company which is doing the meter reading. And then in turn, the meter reading company will send the data to the distribution company. And then based on that, billing will happen. But in AMI, they developed the technology to do the meter reading for smaller interval of time. A particular software will come into picture, which is called AMI interface. So this company will basically read the meters in a particular region, which are all interval meters, collect the data remotely, and this data will come and sit in the local database of the AMI company. But then this company has to send the data to SAP system, which is run by the distribution company. But when this data will come to SAP, how it gets stored? We cannot physically enter any meter reading result like we do in a conventional meter. We cannot do that because there's the interval data. So how to enter this data and how to store? So for this reason, SAP developed the EDM module, which is called Energy Data Management Module. EDM came into existence much earlier. It was available even before ECC 5 or ECC 6, but that time it was not part of the standard SAP. That means when you install SAP, the EDM was not part of the standard SAP. But if companies wanted, they had to buy it as a separate package and install it in the system and pay the user license. But from the ECC 5, EDM became one of the modules, standard modules delivered with the all other modules like device management, billing, invoicing, FICA. So likewise, EDM also became a standard module in SAP from ECC 5. So EDM is basically helping us to manage the interval data. The data which is coming from the AMI company will be stored in the system by using what is called EDM profile. There will be a EDM profile available. This profile is assigned to the meter, the particular meter which is a smart meter, the register. To that, this profile will be assigned. So this profile will store the complete data of the interval for the meter for the particular duration. So let's say we've done the data extraction of the meter reading from the AMI company. It is stored in the EDM profile. The data is available from 01/01/2020 till 31/01/2020. So altogether, it will have 4 readings for 1 hour into 24 hours into 30 days. These many values are stored in the profile. That means profile contains the complete interval data for the period corresponding to 1st of January to 31st of January. But how to build this data? We cannot use standard method of billing where the system will access the meter reading results which are stored in the installation. Based on the quantity 01, we will say so and so is the quantity into so and so price. And then based on that, so and so is the amount. But it cannot keep on calculating the amount for each and every interval data. The access controls are not available for this kind of calculation. So for this purpose, we develop one interface which is called RTP interface. So this interface will work on the energy data, and based on the design of the RTP, it will calculate certain discrete quantity depending on the time of usage. That means the entire consumption what we have in the profile can be segregated into time of usage. Say for morning 6 o'clock to let's say 1 p.m. whatever consumption has happened, we can take it as on-peak consumption. So from 1:15 to let's say 5 p.m. it is, or let's say 7 p.m. it is off-peak consumption, a mid-peak consumption. We can say it's a mid-peak consumption, and from 7:15 to midnight 00, and then till next day morning 6 o'clock, that is 5:45, we can say this is going to be off-peak consumption. So from the profile, the RTP interface will derive the data, segregate them, aggregate them, and then provide discrete quantity. Total on-peak quantity is so much, mid-peak quantity is so much, off-peak quantity is so much. So these quantities are calculated in the interface. That means the quantity information for the billing for the operand will not come from the meter reading results. It will actually come from the output of the RTP. So you make a kind of a integration between the output of the RTP with the operand. So when the billing execution will happen, the system will find out the quantity for the billing from the output of the RTP, and then you can apply different prices. For on-peak duration, this is a price. Mid-peak period, this is a price. Off-peak period, this is a price. So based on that, we can calculate different energy amounts. And also for commercial consumers, we can also use the max demand. That means we can also do the power billing. In the throughout month, what is the peak consumption which has happened for the 15 minutes? Accordingly, what is the peak demand for the whole month? And then we can calculate the demand value, the power value for the particular duration. So the advantage with RTP is we know what is the pattern of consumption, how the 15 minutes consumptions are happening, and then you are able to collect the information, which is the actual consumption recorded for the intervals. And then based on that, we come to know what are the consumptions happening in the different periods of time in a day. And then accordingly, you can have the price pattern and then bill the consumer for different rates of consumption. And usually these smart meters will have the local software, which will help the consumer to take a printout and see how they are consuming. Like at what point of time they are consuming more, at what point in time they are consuming mid rate or low rate of consumption. Accordingly, they can also exercise some kind of control to reduce the unwanted consumptions which are happening, unnoticed or unobserved consumptions which may be happening. They can take some kind of precautionary measures to control the consumption in such a way they can minimize the billing amounts and also help the energy company to manage with the existing resources. Okay, because end of the day, the total supply has to match with the demand. If the demand is used properly, then energy company can supply it. but unwanted, consumptions which are happening are unnecessarily supplied, and also the consumer is paying for that. Okay, but the smart meter will help the consumers also to keep a track of how they are consuming and how they can control the exercise. So the whole idea of interval meter is it is helping the industry in terms of gathering the information which is happening at a small interval of time, and based on this data now the companies can do settlement once in a day or once in a half, twice in a day, or even 15 minutes, settlement can happen, so that we come to know what is the total electricity generated, what is transmitted, what is distributed, and based on that they can carry out the settlement exercises. Okay, so this is how actually smart meters have come into.
Yeah. Good morning, sir.
Yeah, good one.
Yeah, a small thing. You told about smart meters now and the maximum demand part and the RTP billing used in that. Uh, Say, for example, in our organization, we don't use RTP billing, but
Uh-huh.
even for the domestic consumers,
Uh-huh.
when we do the billing, we enter the parameter of maximum demand. We do
Okay.
enter it,
Yeah.
but we don't use the interface as such RTP billing. So
Yeah.
it is being done in a normal way as any variant program is being selected and the rate is defined. So
Hmm.
it is being used in the same way, but no RTP billing as such is used. But
Okay.
still, we use this maximum demand part. It
Yeah.
is
Yeah.
compulsory for each and every consumer
Yeah. Yeah. Yeah.
that we take
I
into
know.
account the maximum demand.
Yeah. Yeah. Yeah, that's okay. That you are doing with the conventional meter. You have got a separate meter for the demand calculation. So just
Hmm.
like you have got energy meter, you will have the demand meter. So every month
Hmm.
you get two readings. One is the consumption quantity, one is the demand. So that you can do
Okay.
anyway with the regular meters. That we will see how to do it. That means you will have
Okay.
two meter. One is the energy
Hmm.
meter, one is the demand
Hmm.
meter. That is separate.
Okay. We will have to maintain two different rates, I think.
Yeah, yeah, yeah. That's right.
We'll have to maintain two different. So
Yeah,
okay, sir. When you go near that, kindly explain that as well.
yeah,
How
yeah,
to do that with a conventional meter also.
yeah, yeah. Sure, sure. Okay.
Yeah,
So
thank you.
now, in order to see how we can use these smart meters in the building, we will do. So first, what we'll do, we'll start working on the device management. We first have to create a new device, which is based on a device category interval meter, and then we have to design a new register group. So whatever steps we have followed earlier in the case of device management, same steps, but there will be some changes in the register group and also in the device category, what we're going to create. So the first step is to create our material master itself. So if we go to MM60, we have got our materials created earlier in the plant, which is 6001. Now, if we go to our technical master data and then go to installation, based on the division 60, 223, and premise is 179, collection object is 89, and our functional location is maintained in the maintenance plant 6001. So our maintenance plant is 6001. For the 6001 plant, we will create now a material master, which is basically representing from the logistic point of view the interval meter, what we purchase, stock, send it to the field. So just like how we created material master, we will do that. Go to MM60. We can find out what are the materials available. We can copy one of them. So 6001, we have created earlier regular meter. Same material number you can select and copy to create a new material. But as far as the material is concerned, there is no change. It is same like how you created earlier, but the difference will happen in the register group and the device category. So 241 we have created earlier as the material master. So go to MM60, MM01, and material will select for plant 6001, that is 241. Industry sector, utility industry, material type, can select any material type, ZMD1, ZND1, or you can use standard material type, HAWE. So 6001 and then 6001. Three-phase alternate current meter, alternate interval meter, then smart meter. Then go to sales and general plant, serialization level, and then go to accounting one, maintain the price, let's say 25,000, and then save. So we have created a new material 291 for which you are going to create a device category, because unless you create a device category, we cannot create a device. But for creating device category, we have to create a register group. So more or less register group will remain the same how we have designed earlier, but we have to add one more data. So we'll create one new register group. So our material is 291 we have created. Now create a new register group. So to create a register group, you go to device management technology, register group, create. The main division category is 01, that is electricity. Enter again division category. So based on that, we'll select accumulating consumption register, RA, active register, average rate. We will say 5 digits before decimal, 2 digits after decimal, and metering unit is kilowatt hour. Active register. Now here we have to enter what is the validation class 0001. Billing unit is kilowatt hour, and we have to enter here the important data interval. This is not entered in the regular meter, so here you have to enter what is the interval it is using. It is using 15 minutes. Okay, that means the consumption is recorded for every 15 minutes. This is important. Based on this only, in future rate type everything will be determined. And you have to enter one register code. The register code is not used in all the countries, but in Germany they are using. So I defined one dummy register code. It's just identifying a industry specific register of a meter. So it is not physically, functionally significant, but it is some kind of an identification which you have to enter. So this is one extra field you are entering. And second extra field what you're entering is the interval duration. That means this particular interval meter is capable of recording consumption for every 15 minutes. So now we will save it and also propose this register during the installation. This is important so that you can enter the relevant data for billing at the register level. What is the rate type? So now we will save it. So register group is 29. RG is 29. Now for the material 291, we will create a device category. So go to select the device category, create, or material number is 291 and division here is 60. We can also copy from the reference device category, which is 241. And then here, previously we selected meter, then transformer, ARCR. Now we have to select the remote meter. Remote meter means it is like an interval meter, the smart meter, what we're going to use. So at the device category level, the remote meter has to be selected. That is what we're going to use. So select remote meter. So three-phase electricity alternate current, smart meter. And then register group we have to change. Our register group is going to be 29. Now here the type of measurement will not matter. Even if you don't enter the method of measurement, it is okay. It is only applicable for the regular meters, okay? But no harm if you maintain. It doesn't have any impact. Now go to certification data. Certification requirement is 1 and the interval is 5 years. So two things are, one thing is different here. The basic category of the device category is different. Here it is meter, but it is going to be a remote meter, okay? I think we should not have copied because it is copying it as a regular meter. So we will not copy, we'll enter a new one. So division is 60. If you're creating another meter only, regular meter, we could have copied, but we have to select here new entry, remote meter. Select the remote meter. So our material number is 291, 291, 60, and then remote meter. So this basic category should be remote meter. So here we will say smart meter, 15 minutes, and register group is 29. Certification requirement, subject to Excel certification, 5 years. So as you can see, it is not asking for the method of measurement. If it is a regular meter in the electricity, it will ask you what is the type of measurement, but here it is not relevant, but you can still enter direct measurement. That means whatever conventional things are applying for the meter will not apply here. That means when you install the meter, you cannot enter any initial meter reading data, or when the moving happens, you cannot enter any moving data, meter reading, because if it is a single value, we can enter, but it is all interval data. So nothing can be entered manually. It has to be read automatically from the profile itself. So we have entered the register group and certification data and then save it. It's a remote meter. As far as the system is concerned, this device category is a remote meter. Now save it. So device category 291 has been prepared. Now we will prepare our device IQ01 291. Manufacturer, you can select anyone. Model number, inspection relevancy 01, and then transfer. So we have created a new device. Serial number is 1133. That is also the equipment number, and then save it. So our serial number is 1133. Device is 1133. So first we have created the meter, and now we have got a remote meter, which is a smart meter, which is basically able to record the consumption for every 15 minutes. Now we have to start designing the billing master data. The method of billing master data customization is the same, but the parameters will change. Okay, we have to create new billing class, new operands, and also new rate schema, rate category. But while defining the rate, we have to see what is the amount you are going to calculate, what kind of amounts you're going to calculate. So the configuration of the billing master data depends on how the RTP interface will be customized. So let us say here, the RTP is going to provide us three types of quantity, energy. One is the on-peak quantity, which is basically consumption happening in the on-peak period of time. Then you have mid-peak quantity, which is a consumption happening in the mid-peak, and then off-peak quantity. So we are going to maintain in EDM time of usage. Accordingly, system will be able to segregate the data, what is happening for on-peak, mid-peak, and off-peak. So we are going to calculate three energy amounts: on-peak amount, mid-peak amount, and off-peak amount. So you're going to use the quantity 01, but then you must have corresponding operands. Operand required for the quantity for the on-peak price, on-peak amount. Mid-peak quantity, mid-peak price, and mid-peak amount. Likewise, off-peak quantity, off-peak price, and off-peak amount. Plus, we can also include the maximum demand. Okay. So you require a variant program to calculate the demand values as well. So we will have to create 4 sets of operand. One set
Sir,
of operand.
kindly also include another component, for example, the rental price, meter rental price.
Rental price will come separately. That is for the regular meters. I will explain you. Same thing you can include here also.
Okay.
You can include Settle 01 variant program. I'll show you that separately. I mean, that's not a complicated thing. It's very simple. But let's focus beyond the, the first concept of RTP, and then we will see how to add the rental also later. So basically, we have got 4 sets of energy amounts to be calculated, 3 energy amounts and 1 demand value. So we have to create here a rate which will calculate 4 values. So for all the energy values, you're going to use quantity 01 variant program, and for the maximum demand, we're going to use demand 01. That's a variant program. So first we'll design the operands required. First we'll define the building class so that we go step by step. So first we'll go to the building master data, go to utilities, contract billing, master data, define building class. Previously we defined one building class as Z600. That is for household with the regular electricity meter, single rate electricity meter. So now we will design Z601 residential, or we'll just simply say smart meter. It is smart meter installations and then save it. So in the installation, you'll be entering building class as Z601. Accordingly, it will have a rate category defined for the particular building class. Z601 is our building class. Now we will go to rate structure and then define the rate type. As you know, rate type is something what you can define permissible at the register level, device level, fax level, interval meter level. Previously, you designed a rate type permissible at the register level, but now we require a rate type permissible at the interval meter. Similarly, in the future, when you're designing the rental price, we want the rate type permissible at the device level, and for the street light billing, fax level. So 4 different types of rate types can be defined. So right now we have defined rate type permissible at the register level, but now we will define permissible at the interval meter. So rate type is Z601, rate type for smart meters. That means this can be assigned to a register of a smart meter. Division is 60 and the billing class is Z601 and permissible at the PIM, permissible for the interval meter. You have to select the interval meter and then save it. Now we will design what we call the rate. Before designing the rate, we have to create the operands. Go to define the operands. So create the operands. Previously, we defined the operand as, you can check what we defined earlier. Although there's no need to do that, we can just go and create, but just for our information, previously we defined some operands. We can see how we have defined. We defined as 60-1, 60-2, 60-3. Okay, doesn't matter. So now we will define the operands accordingly. So go to define the operands, create the operands. We'll start with 500. So 500 is the operand. Operand category quant, that is the energy, and division is going to be 60, that is for electricity. Now previously we selected the operand as register operand. That means it is going to be based on the meter reading results which are entered for the register. Okay, but here we will not have any data for the register because we are not entering any data manually for the register. All the data what is available for the register will be coming from the RTP output. So we have to select it as RTP operand. When we select RTP operand, we are going to connect this particular operand to the output of the RTP interface what we're going to create. That means whatever quantity you are going to bill, that quantity will be calculated using the RTP interface. That's why we are selecting it as a RTP operand. So 500 is the quant, 60 and then RTP operand. So here we will say it is on peak quantity. It is on peak quantity. Unit of measurement, it is kilowatt hour, kWh, and then waiting key 01 and then save it. 501 is the operand for Q price, quantity based price. That is normal usage. It will come from the facts, so normal usage. So we will say this is on peak price. This is on peak price, and this also will be kWh, and then save it. And 502 will be amount, category amount, on peak amount. This is going to be on peak amount. So 500, 501, 502 are pertaining to on peak. Like that, we will create for the mid peak and off peak for the energy. Then we will create the operands for the demand. So now we will save it. I'm going to create 503. So these are the mid peak. Now we'll define the off peak. So we defined three sets of operand for three energy values. The first is 500, which is quantity, that is for RTP. This is also RTP operand quantity, and 506 is also RTP. So these three will help us to calculate the energy amounts. Now we'll create the operand for the maximum demand. Okay. So the operand category is the demand. So 506, 508, let's say 509. So here the operand category will be demand, division 60, RTP operand. This also will come from the RTP operand, max demand, and it will take one peak, that is the highest peak value for the demand, and unit of measurement will be kW because power is in kW. And
Sir, if we
yeah,
create this demand for normal consumer, then what would be our usage? That will be normal usage or registered operand?
which one?
What should we expect? Say, for
Where?
example, if we create an operand for demand for normal
Register, register level.
register
If you
operand, register operand.
register level, yes, because there you're not using smart meter, no RTP, regular register only, regular meter,
And
just like
sir,
energy meter.
can you scroll down a bit, sir? Just this, the left one. Can you scroll down a bit? Yes, please, sir.
Yeah,
Last, sir. This maintainability, sir. Can you let us? I think you had explained me earlier. You had explained us, but this maintainability part, which is in the last, can you just explain whenever, sir, in brief, some thing about that? That when should we take this? When should not we take this?
yeah, sure. I'll let you know. Sure, no problem. We'll do that. So now max demand, number of peaks, and then save it. This is in kW, and then 510. Now for the regular quantity based price, we used to take Q price, but here it use T price, time dependent price. So how it will work, we will see how when defining. So for the regular energy, you used to take Q price, quantity based price, but here the operand category is a time dependent price, that is T price. So 60, we are division, normal usage. So we will say demand price, and this also been kW, and then save it. And then 511 amount. This is the demand amount. So we have designed here three more sets of operand, 509, 510, 511 for the demand calculation. So our 509 is also a RTP operand. That means all the four values will come from the RTP. When you design the RTP, that output will be assigned to the operands during the runtime. When the bill execution happens, the operands will get the value automatically from the output of the RTP interface. So now we will save it. But now, although our operands are ready, we cannot create the rate right now, because when we're creating the rate, we have to select it for the interval meter, and then it will ask for the RTP interface. So let us see what happens if I want to create a rate. So go to define the rate. Let's go to define the rate, create the rate. Jet 601 is the rate. So you can call it as on peak, mid peak, off peak, and the max demand. Division is 60, and our billing class is Jet 601. Now, whenever you're designing the rate is not a free definition, it is permissible. That means the rate is permissible for register, rate is permissible for the interval meter, rate is permissible for the device permissibility, that in the case of rental, or fax permissible if it is a street light billing or period end billing. But here we cannot select the register permissible, because if register permissible, that means you are entering the data for the register manually for the meter reading. But in this case, our data for the meter reading will come from the output of the RTP. So it should be permissible at the interval meter. But if you select interval meter and then continue, it will ask you the RTP interface. Unless you give the RTP interface, we cannot go ahead with the rate. And at the moment, we don't have any interface because the interface itself is defined for the particular division. Okay. So first we have to develop the interface, and once interface is ready, we should be able to create the rate itself. So we'll hold on it for time being. Unless we create the interface, we cannot do. Now to create RTF interface, what all we require? Okay, we'll now go to EDM, SAP Utilities, go to Energy Data Management, Basic Settings, Profile Type, Season Type, Time Usage. Profile Type will come back separately because that is what we use for designing the profile type. Season group, day group, we'll see when you are developing the synthetic profiles, load profiles. Right now, we'll go to time of usage group. Basically, while designing the RTP, we use the time of usage group. Basically, what is time of usage group? We will say our time of usage group is for the total 24 hours in a day. But in 24 hours duration of day, we are going to define certain interval. Accordingly, we'll say this interval consumption is on peak, this interval is mid peak, this interval is off peak. That means we define what is called time of usage type. The time of usage type will tell us what kind of consumptions are happening in which duration. Okay. So tomorrow when you have the profile data, the system should be able to analyze the data according to time of usage and then derive the output, what is required for billing. So first you have to define the time of usage type. Select here. We can create our own new time of usage. Select new entry. So we'll say 6000 is one time of usage, 6001, and then 6002. The 6001, 6000 will say on peak use type, and this will be mid peak use type, and this will be off peak use type. But in which duration these are happening, that you have to enter. So select 6000, select the definition, and then go to new entry, consecutive number 1. Let us say it starts at morning 7 o'clock. Okay, so 0700, and it goes up to, let's say, 13 hours. That means whatever consumption is happening from morning 7 o'clock to 1 o'clock, in that interval, whatever consumptions are happening, if you add it totally, you get the total on peak value. That means your energy data will be available continuously in the form of interval data. But that interval data, when you analyze, we only take out those values which are happening in the period morning 7 o'clock to 1 o'clock as the consumption happening in the on peak. And then when you add it together, you get the total value for the on peak. So now we will save it. So our next period will start from 1315. So we'll start 6001, definition, new entry 1. So here it's going to start with 1350 00 up to, let's say, 19 hours. That's 7 o'clock. So 190000. That means from 1:15 to 7 o'clock in the evening, whatever consumption is happening, this will take it as off peak, a mid peak, and then set. Now, off peak will happen in two duration. That is from 7:15 to midnight. That is happening as the off peak. Again from midnight to next day morning, 6:45 or 6:59, whatever you are taking. So that consumption will be taken as off peak. That means off peak is not happening continuously because it's happening on 2 days. Previous evening from 7:15 to midnight. That's happening on one day. And the next day it is starting from 12 o'clock to next day morning. So we have to enter two slots here. For example, if you see our definition, how we have done earlier, let's say 300, we are seeing here. Okay, we should maintain up to 59.59. Okay, that was having doubt. So we'll slightly modify it. So 600,601 will delete all entries and then save it. While defining, you have to define that way. So new entry 6,000. It is on peak usage type. And then select here definition, new entry 1, 07, 00, 00 till let's say 13:59:59. Okay, up to this particular period of time, it's going to be on peak, and then save it. That means from 14 hours will start the next duration. So select 6001 mid peak use type, and then this will start from 14 hours. Select here definition, new entry 1 till evening, let us say 19 hours. It's going to be till 19 hours, or you can say 18:59 and then 59. That means whatever consumption is happening from 2 o'clock to afternoon to 18:59 will be basically the mid peak. That means our off peak will start from 19 hours, that is 7 o'clock. So 6002 off peak, but off peak will happen in two duration. You have to maintain two duration. So select definition, new entry 1. So it is starting from 19 hours till 23:59:59. That means up to midnight, 23:59:59. This is one duration. Then second will start from 00, that is from midnight, till next day morning. Our on peak is starting from 7 o'clock in the morning. So 06:59 and then 59. That means in this period, during these two duration will have the two off peaks happening. Why you're not taking continuously? Because in the interval data, it will not only the time, but also date will come into picture. That means the 9 o'clock, 7 o'clock to night 23:59 is happening on one day. And from next day, midnight to 6:59 in the morning, it will be, again off peak. So we are splitting into two. So you can just check once the definition correctly. So 6,000, it is starting from 7 o'clock, going up to 13:59, and then from 14 hours to 18:59, and then it is starting from 19 hours, going up to 23:59, and from midnight to 6:59. That means it will come to again 7 o'clock. Okay, 7 o'clock as a period. After defining a time of usage, we have to group them into time of usage group. That means when you use that group, we know what are the time slots. In some companies, they may use only on peak and off peak. Some companies, they may use on peak, mid peak, off peak. So the time of usage group is defined for one complete date, that is 24 hours. But in that 24 hours, how we are going to design the time of usage. For that purpose, we require the time of usage group. Select it and then define the new entry. We will say 6,000 is the TOU group, time of usage group. And to the group, we will add the definition of the time of usage. One is 6,000 and that is 6001, and the third is going to be 6002, and then save it. So we have defined a time of usage group because this time of usage group is required in the RTP component. The next design will be RTP component. And once the RTP component is ready, we should be able to design the RTP interface. But when you design the RTP component, we require the time of usage group. Okay. So now, having done this, in the tomorrow session, we will see how to design the RTP components. We require two components, one component for the on peak, off peak, mid peak, and one component for the max value. So before designing the RTP component, we will try to understand what is the purpose of RTP component, why it is required, and in which way the component will play a role in the design of RTP interface. So tomorrow we'll first work on the RTP component. We'll be designing two RTP components, one for the on peak, mid peak, off peak energy values, and one for the demand value. And once these RTP components are ready, we are going to define the RTP interface. And once the interface is ready, we will create the rate. And then we will connect the output of the RTP to the operand values in the facts, so that, when the billing will happen, the system will take the value of the RTP operand to the quantity which is coming from the RTP output. Okay. So tomorrow we will see how to design the RTP interface. Is it okay? Shall we close for today? Okay, fine. Tomorrow.